Okay, we're continuing with 9.1 and 9.3. It's all solving quadratic equations, but here we're using the quadratic formula. So we write this in standard form, which means I'm moving the 7 there. Identify A, B, and C, and rewrite my quadratic with parentheses. Fill in my A, B's, and C's, and now I'm going to simplify. So that's -4 plus or minus here, 2. This is going to be 16. 2 negatives is going to make a positive. 4 times 7. 28. I need my calculator. Alright. 16 plus 28. Alright, 44 is not a perfect square. So here, we are going to leave this in simplest radical form. So I need to simplify this. So what perfect square factor can I pull out of here? Well, it's divisible by 4. And it leaves me 11, and that's as low as I can go. So if this is 4 times 11, 2 comes out. So I have -4 plus or minus 2 square root of 11 over 2. Now I know this notation is odd, but these are two terms. They have a GCF of 2. -2 plus or minus square root of 11 all over 2. So this 2 simplifies out, and I'm left with -2 plus or minus the square root of 11. So here, if all 3 can be divided, you can do it right here. Or you do it like this. So we're continuing to solve quadratics using the quadratic formula. So here's my formula. The x squared is positive over here, so I'm going to bring everything to this side, and it will have the opposite signs to identify A, B, and C. Rewrite my formula with parentheses. Oops, not the A, parentheses. A is 1. C is 1. I don't know why I did C then, but -1 for B. So +1 here. 2 on the bottom. This turns positive. I only have one negative sign, so this is going to be -4 times 1, 1. So -4. Which leaves me with -3 underneath the square root, which I can't have, so I have no real solutions. So once you get a negative under, once you get a negative under the square root symbol, you stop. There's no real solutions. Go up to here. I'm going to bring the 3 over. A is +5, B is -8, C is -3. Plug in my A, B's, and C's. A is 5, B is -8, C is -3. This will turn to +8. 10 on the bottom. This will be +64. 2 negatives make a positive. 4 times 5 times 3 is 2060. So we're going to need to simplify this, put this in simplest radical form. 124 is not a perfect square. I'm going to start with dividing by 4. It's my first perfect square factor. 31 is prime, so that's actually as much as I could do. Can we see this? Yes. So the 2 comes out. I still have a factor of 2 that I can simplify out of here. So if I pull a 2 out, I'll have 4 plus or minus square root of 31 over 10, and that reduces 4 plus or minus square root of 31 over 5. Continuing to solve with the quadratic formula, it's in standard form. Rewrite my A is 1, B is positive 4, C is positive 4. Simplify. This is going to be positive 16 minus 16, so that goes to 0. So plus or minus nothing is nothing, so we're just left with negative 4 divided by 2 is negative 2. So I only have one solution. I could have factored this easily, but it also works with the quadratic formula. Standard form. Rewrite my formula. My A is 2, B is 8, C is 1. So negative 8 plus or minus 4, 64 minus 4 times 2, so 8, so 56. Which I'm going to try to simplify. Divide by 4. And that's as low as I can go. So I'm going to pull out a 2 out of all 3 of these terms. So my solution is going to be negative 4 plus or minus square root of 14 over, that reduces to 2, and that's all I can do because there's only a 1 there. That's in lowest terms.